Hello, I'm Anna Mackay, and in this video we're looking at confidence intervals for proportions and also combining that with testing claims about P, which is the true population mean. Here's our official formula for a confidence interval. If your sample proportion is P hat, which is the equivalent of X bar in normal statistics, here's our confidence interval. I encourage you to look back at my video on confidence intervals, even though it's for normal distribution, because it'll give you a big background as to how this formula is derived. Essentially, we've got the true population mean here, P in the middle. Notice it's P, not P hat. And then this is the amount of variance, if you like. So it's 1.96 standard deviations around the population mean there. And that 1.96 gives us that width of 95%. So we're doing one example here that will cover F.1 and F.3. So if we have a newspaper article that stated that 2 out of 3 South Australians do not know when daylight savings ends, and a survey of 2,467 South Australians is conducted, and of those in the survey, 1,608 do not know when daylight savings ends. So using that data, we have to calculate a 95% confidence interval for P. Now P is the proportion of all South Australians who do not know when daylight saving ends. So when I do one of these questions, I like to find the numbers that are in the question and to write them off to the side so I'm quite clear what I'll be working with. Noting that they claim 2 out of 3, so that's 2 out of 3 would be the claim for P, and therefore my P hat is X divided by N. X is 1608 and N is 2467. So we're going to put that in our graphics calculators now. We're in the stat menu and we're doing confidence intervals. So we're going to choose interval F4. It's a Z value, and this time we're in proportion, not a sample. Although you might say, well, a sample has been taken, but it's binomial, so we've taken a proportion. And the values that we need off to the right here are our confidence interval is 95%, so 0.95. Our X value is 1608, and our full number in the sample, 2467. And the interval that we get for that is here. I'll write that back on the other screen. Notice that it does give you your P hat value, which is the X divided by N, 0.65 rounded to 2. So the two endpoints there were 0.633 and the upper end was 0.671, and you can put greater than or equal to. And what goes in the middle? P or P hat? It's P. It's an estimate for what the true proportion would be of South Australians who don't know when daylight savings ends. If you sampled every single South Australian, you're saying that the true mean would lie between those two endpoints. Now have a think what the claim was, 2 out of 3. What decimal would that be? And that's what we're going to go on to look at. So the claim of 2 out of 3, the decimal for that would be 0.6 recurring, so 667 if you like. And the question here is, do you consider that the survey data provides evidence that the newspaper's statement is wrong? So this 0.667, where does it lie within this confidence interval? It's above the lower endpoint. Does it fit in before the upper endpoint? It does actually. So the claim is not wrong. Let's write that as a sentence. So there's many ways you could answer this sentence. The one I've chosen to answer with is, since the newspaper's claim of 2 out of 3, 0.667, it's always a really good idea to include some numbers in your worded answers, lies within the CI, feel free to abbreviate confidence intervals to CI. The statement is not wrong and could be possible. The key here is that it lies within, so it's a possible value. Now we're asked to explain why it is not reasonable to claim that P, the true proportion, is 2 out of 3 exactly. And that's because every value within this interval here is equally likely. So unless we surveyed every South Australian, we won't know what the true proportion is, and so every value in here is a possibility. I'll write that now. So my answer as to why it's not reasonable is that every value in the confidence interval, again I like to include some numbers to back that up, is just as likely as the others. Without surveying every South Australian, we could never know the exact value of P. Part D. Using your answer to Part A, suggest a reasonable claim for the possible value of P. So Part A was calculating this interval here. I'll write two possible claims that we could write. So one claim here, more than 63% of South Australians do not know when daylight savings ends. Now, you might argue that 63% is actually not within this interval, and you'd be right. So if you feel more comfortable writing 64%, you go for it. Or you could just matter-of-factly say 63.3 to feel comfortable. I guess in this point, you know, if you're a newspaper, it would be okay to round to that whole number there. And so this is a fact, yes, more than 63%. Do not know. Now, that subtly implies that it could go up to 70, 80, 90%. Now, we can see from our confidence interval that that doesn't happen. But hey, if you're a newspaper, you know, a claim like that, that sounds good. If you'd prefer to write a range for your claim, here's an alternative. I'll just summarise it there. You might claim that between 64 and 67% of South Australians do not know when daylight savings ends. Again, if you prefer to not do whole numbers, you could do 63.3 and 67.1. That is a true claim, so that would probably be more accurate than saying exactly 2 out of 3. And last part here, let's say there was a different online article in the same year that claimed that 70% of South Australians do not know when daylight savings ends. Now, based on that survey, based on the survey that we did, is the claim wrong? Is that 70% claim wrong? Yes, it is. Why? So the answers that we're after are either that it lies outside of the confidence interval. We preferably like to indicate direction, so it lies above, or you can flip that and say it doesn't lie within the confidence interval. So I'm going to write that. So summarising that, we say yes, the claim is wrong since 70%, so you reference back to that number, lies above the confidence interval, so that's the key word there, above, or the confidence interval is completely, if you like, below 70%. Subscribe to the channel, give it a thumbs up, join me in the next video, 9F.2, sample size for proportions. Thank you.